Hello class. Today we are looking at simplifying fractions again. So our essential question is, how do I simplify fractions? My learning intentions are, I am learning to simplify fractions, and then you've got a warm-up. Answer either true or false for the following statements and give an example. So, pause the video and see if you can go through the next 4 statements and answer true or false. Well, I hope you try it on your own. Then if you get the answer right, you know you're understanding the concept. So first we have to know what that funny looking R stands for. That stands for the real numbers. Are the real numbers closed under multiplication? Yeah, they are closed. That is a true statement. You can use any two numbers and multiply them. You could take 2/5 times 5, and that gives you 2. So it doesn't matter if it's a fraction or a number or a decimal. You can multiply any two of them together and you'll still get a number that lies in the set of real numbers. Okay, what does the Z stand for? Z are the integers. Are the integers closed under subtraction? Remember, your integers are 0, 1, 2, 3, and -1, -2, -3. Yes, they are. That would be a true statement. And I could have -5 minus -3, and that would give me -2. We don't minus the negative, we plus the positive. The N stands for what set of numbers? The natural numbers. Those are the ones we learn first because those are also called counting numbers. Are they closed under addition? Yeah, because a positive plus a positive gives you another positive. So this would be true. And I could put 2 plus 100 is equal to 102. Any two numbers. Add them together and you'll get another natural number. What about the Q? Do you remember what that funny looking Q stands for? Those are our rational numbers. Are they closed under division? So when you're thinking of a statement like this, you're thinking, is there any number I cannot divide by? Because if there's that one number I cannot divide by, then I know it will not be closed. Is there any number I cannot divide by? Yes, I cannot divide by 0. That's undefined. So this would be a false statement because 5 divided by 0 is undefined. Okay, so as you look at this, you're looking at the statement, and you have to think about everything that can happen. If we're adding, what are we adding? Well, they're all positive numbers. Positive number plus a positive number is a positive number, so that's why the natural numbers are closed. If we're subtracting, we're looking at integers. We've got positive and negative integers, so we know that there's no way to get a fraction when you're adding two integers together, so it would be true. Multiplication is true because we can multiply any two numbers together. There's no restrictions. Okay, so let's get down here to simplify. The first thing I always have to think of is, what are my factors of? Well, my factors of 12 are 4 times 3. Do I also have a factor of 4 in 20? Yes, I do. I know that 4 divided by 4 is 1. This is canceled out because multiplying by 1 is our identity property. So I'm left with 3 over 5. Okay, 4 over 8. When you're doing this, think logically. 4 is what part of 8? That gives you the answer 1/2 right there. Not the only way to do it. So I know that the factors of 4 are 2 times 2 times 1. But it's also 4 times 1. Do I have a factor of 4 and 8? Yes, 8 is 2 times 4. So this is 1 times 4 over 2 times 4. I have to remember to bring my negative sign over. The 4's eliminate each other. They become 1, and when I multiply by 1, nothing changes. So this is 1/2, and it's negative. This is the way I hope you can get to where you realize, looking at that 4 is 1/2 of 8, and that would be simplifying it. Okay. As we're looking at this, we need to think of our common factors. 30 is even, it's divisible by 2, but 35 is not divisible by 2. 30 is divisible by 3. 35 is not divisible by 3. So those are the first two prime numbers. The next prime number is 5. 30 is divisible by 5, and 35 is divisible by 5. Five times 6 is 30. 5 times 7 is 35. And one of these two has to be a negative. It doesn't really matter which one it is. Okay, my 5s will factor out. I've still got the negative sign. Negative 6 over 7 would be that simplified form. Okay, so if the numbers are smaller and you have a good grasp of your multiplication tables, you just need to start looking for that least common, that factor that goes, the greatest common factor that goes into both of them. So now let's look at the next one. The next one is a little bit more involved. I am actually going to find all the factors. Okay, 125. I can divide it by 5. That I can't divide by 2, I cannot divide by 3, so 5 is the smallest prime number I can divide by. 5 goes into 12 2 times, that gives me 10. I'm left with 25, so that I divide it by 5 and it's 5. 25 is divisible by 5. 25 divided by 5 gives me 5. 5 is divisible by 5. 5 divided by 5 equals 1. So the factors of 125 are 5 times 5 times 5. We're going to do the same thing for 325. Okay, I can't divide by 2. I can't divide by 3, but I can divide by 5. 5 goes into 32 6 times. That's 30. I'm left with 25, so this would be 65. 65 is divisible by 5. 5 goes into 6 one time. 5 goes into the 15 because I've got one left over 3 times. What do we know about the number 13? It is prime. So I divide by 13, I get 1. When I get 1 at the bottom, I know I'm done. So 325 is 5 times 5 times 13. Once again, anytime we're multiplying by 1, it will not change the number at all. So our final answer would be 5 over 13. Okay, if you're still struggling with this concept, back the video up and watch it again. The next concept we look at is adding and subtracting fractions. To be able to add or subtract fractions, you must have a common what? Denominator is correct. Just a quick review. If you have a fraction, the top number is your numerator, and it is over your denominator. Whoops, I spelled that wrong. I knew it did not look right. So what we're talking about having to have a common one of is that bottom number. So if they're not the same, then we have to find an equivalent fraction with the same denominator. So the first one is easy. I look, I've got 2 at the bottom on both. So that tells me all I have to do is to add the top numbers together. Okay. 1 plus 3 is 4. When I divide 4 by 2, I end up with 2. For the second one, the same thing is going to happen. I've got that common denominator, so I just pay attention to the top numbers. 13 minus 7. 13 minus 7 is 6. 6 divided by 3 is also 2. But what happens if I do not have a common denominator? The next one is an example. I've got 3 and I've got 6 for denominators. I've got to change one of the two or both. So the first question, I'm going to look at the smaller number and ask myself, will 3 divide evenly into 6? 6 divided by 3 is 2. So I know that I can change the first one, but I don't have to, but I don't have to change that second one. I can put them both in terms of sixths. So I've got to change 2 over 3 to something over 6. So I'm going to think, what do I multiply 3 by to get 6? I'm going to multiply it by 2. Whatever I do on the bottom, I've got to do on the top. 2 divided by 2 is 1. So what I'm actually doing is multiplying by 1. 2 times 2 is 4. So 4 over 6 and 2 over 3 are equivalent fractions. Now I'm ready to perform the operation. 4 over 6 minus 5 over 6 is equal to. Now all I have to worry about are my numerators. The bottom number, my denominator is 6. 4 minus 5. 4 minus 5 is negative 1 over 6, and I'm done. So if they're both the same denominator, you're great. If one of them is a factor of the other, it's easier. But what if they're neither one a factor? Then you have to look and think. I've got 5 and I've got 3. I'm looking for my least common multiple. Actually, my greatest common multiple. Oh, sorry, that was correct the first time. I want the smallest number both of them go into. So I'm looking at my least common multiple. Okay, if they're both prime numbers, it's easy, I just multiply them together. So in this case, the LCM is going to be 5 times 3, which is 15. Okay, so let's do our conversion now. 4 over 5 is equal to what over 15? Once again, I've got to think. 5 times what gives me 15? Well, the answer is 3. So I've got to multiply this by 3 also. I'm multiplying by 3 over 3, which is 1, which means it makes an equivalent fraction. 4 times 3 is 12. So the first number is 12 over 15 plus. Okay, I've got to do the same thing with the 2 over 3. Once again, I have to think. 3 times what gives me 15? Well, 3 times 5. I'm going to multiply the top by 5 also. 5 divided by 5 is 1. That's why it works, and that is 10. Plus 10 over 15 is equal to 22 over 15. 22 over 15 is simplified. It's an improper fraction, but we will be working with improper fractions. So how do you know when you're successful? When I can simplify fractions, find a common denominator, and add or subtract those fractions. So we are adding and subtracting fractions.